As was mentioned, TEDx conducted the scientific review for the EDCs in the 2011 release, and at that time I did a video presentation, so it's really nice to be here and see how a launch is carried out. It's exciting. It's exciting to see all the materials and to see all the interest of the audience, so thank you. Let's see. Okay, I wanted to tell you a little bit about TEDx. TEDx has been providing practical scientific information to policymakers, environmental and public health agencies, non-governmental organizations, academicians, and many others for 10 years now. We do this by seeking out, selecting, reviewing, and interpreting scientific research relevant to endocrine-disrupting chemicals. As was mentioned, and many of you know, Dr. Theo Colborn is the founder of TEDx, and she's widely recognized as having pioneered the field of endocrine disruption. So as not to have too boring of a scientific presentation, I've put a lot of photos in here, and I wanted to put a face on the project. This is our scientific staff that worked on the ChemSec list. Ashley Bolden managed the project. She's here and may help me answer some questions later if they're technical in nature. She has a Master's of Science degree in Integrative Physiology from the University of Colorado, where she worked in the Comparative Environmental Endocrinology Lab studying reproductive and behavioral effects of EDCs. And then along with Ashley is Johanna Rochester, who's on the left in the photo. And she also helped conduct the scientific work for the project. She has a PhD from the University of California, where she studied environmental estrogens, followed by a postdoctoral position at the University of Colorado investigating reproductive brain hormones. And then Lynn Carroll on the right, she also assisted on the project by creating and conducting all the literature searches. She's an entomologist with a PhD from Texas A&M University. I mainly provided oversight and supervision, and I served as a liaison with ChemSec. My PhD is in cognitive behavioral science, and I've been the executive director of TEDx for 6 years now. So I wanted to start by talking a little bit about the endocrine system. The endocrine system is an extremely complex network of chemical interactions, and few people outside of the scientific and medical communities really understand the full scope of the endocrine system. Within the span of the next few minutes, I am going to try to touch on the most salient points for the purposes of this presentation, and I'll try to keep that brief. As shown in this slide, the primary endocrine glands and organs where the hormones are produced and secreted are shown in the picture and listed there. The ovaries, the testes, the adrenals, and the thyroid are the most well-known endocrine organs, but people don't often consider that other organs, such as the heart, the gastrointestinal tract, the kidneys, and several structures in the brain, even fat tissue, are also endocrine organs that produce and secrete hormones. Even the skin, the body's largest organ, is an important endocrine organ, serving as the interface between our external and internal environments. There are upwards of 50 different known hormones that bind to hormone receptors all over the body, each participating in a cascade of signaling events that involve signal activation, inhibition, feedback loops, and many other types of interactions. And I think that phrase, a cascade of signaling events, is a good one to remember because it's really the heart of how the endocrine system works. Through this dynamic process of sending and receiving chemical signals, the endocrine system influences how we develop, grow, and mature, how our reproductive systems function. It influences our intelligence and behavior, our sleep patterns, appetite, thirst, metabolic level, and fat storage. It also influences our response to stressful situations and our ability to fight illness. Hormones also influence all the things that you regularly get checked at your physician's office: blood pressure, blood sugar, cholesterol levels, bone density, and more. Endocrine disruptors, quite simply, are exogenous chemicals from outside the body that interfere with normal hormone action. If you know anything about EDCs, you've probably heard that they bind to hormone receptors. These receptors are located in cells all over the body, and when EDCs bind to them, they can mimic normal hormones, they can block them, and they can interfere in any number of ways that disrupt the normal signaling cascade. But EDCs don't just bind to receptors. They can also affect the synthesis or production of hormones, the transportation or how they move throughout the body, and also their metabolism, in other words, how they're broken down and the body disposes of them. And there are many other potential mechanisms, some of which have not even been discovered yet. So I want to talk a little bit about our reasons for concern around EDCs. We know that exposure is widespread in the general population. EDCs have been found in just about every tissue ever tested, every person ever tested, and they're found in many different fluids like blood, urine, stool, saliva, tears, perspiration, placental tissue, umbilical cord blood, and even the meconium of newborn babies. Some EDCs remain in the body for years, and others are excreted rather quickly within a matter of hours or days. And the average concentrations of EDCs are typically higher in children than in adults. We also know that there's potential for a wide variety of downstream effects in the body. EDCs have been implicated in infertility, endometriosis, early puberty, breast and prostate cancer, thyroid disorders, Alzheimer's and Parkinson's disease, ADHD, autism, asthma, immune dysfunction, diabetes, obesity. This really speaks to the pervasive nature of how the endocrine system works in the body. And it's a reason why it's important to keep the definition of endocrine disruption broad and not to narrow it down to just a few systems or hormones. It's a serious concern that we might fail to identify a chemical as an endocrine disruptor simply because we failed to look at the system where it exerts its effects. Another reason for concern is that the effects of EDCs have been shown at the low exposure concentrations found in the environment. Of course, this makes sense. Hormones function at extremely low concentrations, in parts per trillion. This has been compared to if you had 20 Olympic-sized swimming pools, a part per trillion would be 1 drop of water in that entire quantity of water. And many different studies have demonstrated that endocrine disruptors have effects at the low concentrations, including studies in wildlife populations, which is where endocrine disruption was first recognized. One of the most concerning aspects of EDCs, in my opinion, is that effects from prenatal and early life exposure can be permanent. In the early weeks of pregnancy, stem cells, which can become anything, they begin to differentiate into what they will eventually be: testicular cells, heart, thyroid, or fat cells, or brain cells. And research demonstrates that this is an incredibly vulnerable time in development, and one in which exposure to EDCs can lead to permanent changes in development and function, changes that may not be expressed until much later in a person's lifetime. It's also true that effects can occur in multiple generations of offspring. This can happen through direct exposure to the pregnant mother, to her fetus, and to the germ cells that are beginning to develop in that fetus. So those are 3 generations that are exposed in that moment, as well as there's research showing effects on subsequent generations that were not directly exposed. Clearly, we have many reasons to be concerned about the impact of endocrine disrupting chemicals. So the first step is to identify which chemicals are EDCs. And that's where we get into what we did for the ChemSec project. We started with the goal of finding all the evidence to date on the health effects and endocrine mechanisms of the proposed sin-less chemicals. To accomplish this, we employed systematic review processes. Systematic literature review relies on explicit structured protocols to identify, evaluate, and synthesize a body of scientific evidence. It's generally regarded as providing the highest level of medical evidence to support recommendations for clinical practice. At the U.S. National Toxicology Program, the Office of Health Assessment and Translation, known as OHAT, recently designed a systematic review protocol specifically to address environmental health questions. And we adopted this rigorous scientific approach in our work for ChemSec in order to provide clear justification for inclusion of the selected endocrine disruptors in the SIN list. So here's our process. First, we performed comprehensive literature searches on 25 different chemicals. Using custom software programs designed for systematic review, Ashley and Johanna independently screened over 70,000 studies, reviewing abstracts and titles in order to find studies that were relevant. Examples of studies that were excluded at the screening process, or at the screening stage, were case studies, review articles, measures of chemicals in the environment or in people, and a variety of other types of research that did not measure physiological effects of chemical exposure. And given the potential for a wide variety of endocrine-related effects, we included all physiological endpoints in the initial search. And of course, we kept studies with both positive and negative research findings. In other words, studies that showed significant effects and those that did not. In total, over 400 studies were selected for evaluation. Very few of them were conducted in humans. Roughly half were conducted in various species in vivo, and the other half were in vitro. For the human and in vivo studies, standardized study quality questions were used to judge the strength of the study and the validity of the findings. Key questions addressed whether the methods used to measure exposure and outcomes were valid, were they reliable, sensitive, and were they consistently applied across comparison groups. Other questions assessed factors such as randomization, blinding, attrition, confounding variables, and statistical methods. And then in vitro evidence was evaluated for the degree to which it provided mechanistic or biological plausibility of an endocrine effect and for its applicability in humans. The 400-plus studies obtained for full review were read by 2 scientists, and data were extracted and entered into a database, then cross-checked for accuracy. The methods were documented, for example, the dose of the chemical and how it was administered, the age of the exposure, and the age of the outcome measurement. And results were entered including what system was affected. Was it the endocrine, immune, or nervous system? What hormones were involved? Were there developmental effects or male or female reproductive effects? What organs and glands were affected? The adrenals, the thyroid, or the pituitary? All of this was captured in the database. My slides are a little out of whack, too. Yeah. So finally, we wrote up summaries for each chemical, primarily focusing on estrogen, androgen, thyroid, and neuroendocrine hormones, and on reproductive, developmental, and neurological effects, including behavioral effects. And I want to clarify that there are many other steps in a full systematic review that we didn't conduct as they were beyond the scope of this project, but we did the study quality evaluation and the data extraction that I described. So at that point, the information was in the hands of ChemSec as they began the decision-making process to select chemicals for inclusion in the SIN list. And as others now begin to engage in making decisions about these chemicals, I want to emphasize that although economics and other variables are important to consider, we should always keep in mind that the most important goal is health. And if we could imagine for a minute that substituting these chemicals could actually change the rates of illness. Imagine a world where rates of asthma, ADHD, and autism actually go down, where the typical family does not have 3 generations, parents, children, and grandparents, all with health conditions, where EDCs are a thing of the past. I know that's a lofty goal, in my opinion. But I say let's aim high. Amidst the current buzzwords of economic growth, competition, and efficiency, we have to remember that a productive society requires a mentally and physically healthy population. And again, I want to thank all the staff at TEDx, especially Chris Ribbons, who I didn't mention earlier, but she downloaded and processed all of the hundreds of scientific papers that we reviewed. And thank you to ChemSec for the incredible work they're doing to support a future where protecting human health and inspiring product innovation are one and the same.